Hello class, today we're going to be talking about a permutation and combinations all together. But most likely for today, I'm going to go over just to review more on the permutation portion before we move on to combinations starting this week. Now remember that permutation was ways of arranging things in order, and we have done a lot of questions regarding those. So let's consider this question. There are four candidates for a job. The members of each of the search committee will rank the four candidates from strongest to weakest. How many different outcomes are possible? So if we're going to order four people in four different spots, I believe that there were two ways to do it. There was a way to make blanks, like 1, 2, 3, 4, or there was an actual formula for permutation, which was NPR was n factorial over n minus r factorial. Either way will work out perfectly. So in this particular case, we're choosing out of four candidates and we're arranging them from strongest to weakest. So we have four spaces and we have four people to choose from. So it'll be 4, 3, 2, 1, and the answer will be 24. The way that to do it here is 4p4, and you can type that in your calculator and you'll get 24. Or plug it into the formula, 4 factorial over 4 minus 4 factorial. And we always established how 0 factorial was 1, so we just do 4 factorial on the calculator, it also gives you 24. Pause the video, and please try doing these two questions for me. Okay, so here, how many ways is it possible for 15 students to arrange themselves among 15 seats? Now, this was one of those examples I shared with you last week where you're arranging 15 people in 15 different spots. So it'll be 15p15. Using the formula or using the calculator, if you have an access to one of these, you should be able to find out what the answer is going to be, which was 15 factorial, which gives you 1.307 times 10 to the 12th power, which means there's a lot of them. If it's not possible for you to fit the numbers in, this is perfectly fine. I can just say 1.3 times 10 to the 12th ways in which this could be arranged. There are 8 greyhounds in a race. How many different orders of finish would there be possible? First place through 8th place. That's same thing, 8p8, which is same thing as saying 8 factorial, which should give you 40,320 different ways. Okay, so next couple questions here is now we're going to have a password questions. For these also, I want you guys to pause the video and try these on your own. Okay, so for number 1, the password for Gomer's email consists of 5 characters chosen from the set GOMER. How many arrangements if there's no repeated letters? Okay, so we have 1, 2, 3, 4, 5. We have 5, 4, 3, 2, 1 options to choose from. So this should be in review for you guys. There should be 120 different ways. How many 5-character words are possible if a password may be repeated characters? For number 2, if you do the blanks, it should be 5, 5, 5, 5, 5. Now notice, this is not the same thing as saying 5p5. It can't happen because the repeated letters are possible. No longer is this formula going to be valid. So it would be 5 to the 5th power, which gives you 3,125 different ways. Okay, so Gomer has 20 books and needs to put them on the shelf. How many different arrangements is possible? Now this is another way of giving you an example, comparing this to this. And then Gomer is going to choose 9 out of the 20 books. Now for these two, you should know it's 20p20, and this should be 20p9. It should be very, very simple how to solve these types of questions here. Okay? All right, so there are going to be more permutations questions, but if you have forgotten the formula, I've already given you this. There are 10 candidates for a job. The search committee will choose 4 of them and rank chosen from strongest to weakest. How many different outcomes are possible? For this one, we do NP10, and you get the answer right away. So it seems like all these permutation questions are going to be pretty simple, and I'm going to give you questions like these to do. Password first, second, and then making the passwords or arranging them in a line, and these types of questions here, along with these two. Now, I want to go over combinations just a little bit before we end the video. Now, combination is ways of arranging things without order. So if permutation meant that you're going to arrange things with order, combinations is the one that it's the one without the order. Now, going back to the topic that we have just described above here, There are 4 candidates for a job. The members of the search committee will rank the 4 candidates from strongest to weakest. They give you that criteria. Now here, when we say that there are 4 candidates for a job, the members of each search committee will rank the 4 candidates from strongest to weakest. This is the same exact question, but I am going to switch this around. If I erase this, and they say the members of each search committee will rank the 4 candidates, instead of saying rank, we'll group the 4 candidates, let's say. How many different outcomes are possible? So what that means is, let's say that there are 4 candidates for the job, A, B, C, and D. The members of the search committee will group the 4 candidates in how many different ways? So how many different ways are there how many different ways are there to group these 4 candidates without any specific order? Now, the specific order that was mentioned in the permutation was from strongest to weakest. In combination question, however, they will not specify that. There is no specification as to how to group these candidates. So if there are no criteria in which how to group them, if I group them like A, B, C, D, or A, B, D, C, or B, A, C, D, all of these are a way to group the 4 candidates, but they are all you're not going to count them twice or 3 times. How many different ways can you group 4 people into a group of 4? There's only going to be one. So in combination, we use the letter C. If you're trying to group 4 people into 4 different spots, there's only one way to do that. Why? Because A, B, C, D, A, B, D, C, B, A, C, D, they're all counted the same. They're all same 4 people. It's just they're different locations, but who cares? If I ask you guys to get in a group of 3, and if 3 of my students get in a group, doesn't matter how I arrange them because that's one way to group the 3 people. So doesn't matter whoever comes first or whoever comes last. It doesn't matter. So that is a combination. If I did 4P4, which was the answer to this question very back in the beginning, I have 24 different ways in which I can arrange 4 people in 4 different spots. But if we're talking about combinations all the way down here, notice how there's only one way to do so. Now here, this is the combination formula. You will notice that it's only the permutation formula with the exception of this r factorial. So when we're considering permutation, there are going to be a lot more permutation ways than combination ways. Because permutation means that the order matters, so multiple things, like even though they're the same 4 letters, multiple ways in which that they can be rearranged counts more than once. Combination, on the other hand, you just count them once. Doesn't matter what the specification is. So there are going to be way more permutation ways if we're given the same situation. Okay, so let's take a look at one more example. A pizzeria is offering a special for you. For $6, you get a 4-topping pizza. The choices of the toppings are pepperoni, sausage, olives, mushrooms, anchovies, peppers, and onions. So that's 1, 2, 3, 4, 5, 6, 7. 7 different toppings to choose from. How many different 4-topping combinations are possible, assuming that no topping can be repeated? So, if this was the case, whenever I give you guys these types of questions, you need to first understand whether this is permutation or combination. That's a question mark. Does the order matter when you're making a pizza? When you're making a pizza, when you put black olives first and then pepperoni, or pepperoni first and then black olives, do you get the same pizza? Well, absolutely you do. So the order of the toppings in a pizza does not matter. So what you're going to do is, this is a combination problem. Number 2, execute the formula. Once I understand that it's a combination problem, I can do NCR, which is I'm choosing out of these 7 toppings, and I'm choosing 4. So 7C4 is what I'm going to type into the calculator, or I can do 7 factorial over 7 minus 4 factorial times another 4 factorial on the bottom. So if I do the formula, I should get 35 different ways in which this could be possible. Or if I do 7 factorial over 3 factorial times 4 factorial, that would mean I have to do 765 divided by 6, which should also give you 35 different ways to do so. So this would be an example of a combination problem. I'm going to give you guys these two examples along with some permutations question to do. So you have to be able to distinguish. The biggest topic for this week is, are you able to distinguish between the permutation and the combination? That is what a lot of kids struggle with, and it's something that also that the teachers struggle with as well. We have to practice that a lot for this week, and then we're going to be taking a quiz at the end of this week as well. Make sure you do your homework. It's going to be 4 questions dealing with permutations and combinations due by, because I've uploaded the video late, I'm going to give you guys until 8 a.m. by, no, actually, no, I'm going to give it to you by 12 p.m. by tomorrow. Okay? Thank you and have a good day.